In this video, we will solve a variety of problems involving angles, arcs, chords, secants, and tangents. In the back of our minds, we will hold these formulas relating angles and arcs, depending on whether the angle is at the center, on the circle, in the circle, outside the circle. And we also have these relationships relating segments, whether inside the circle like this or outside the circle like this. So there's 5 formulas you need to know, plus this theorem that says if you have a quadrilateral inscribed in a circle, opposite angles are supplementary. We'll have to know that as well. All right, but back to this. Let's start with problem number 1. And hey, there's that quadrilateral I was just talking about. Again, when you have a quadrilateral inscribed in a circle, meaning the vertices are all touching, opposite angles are supplementary. So these two angles are opposite angles, right? They are across from each other. These angles are supplementary. They're not equal, they are supplementary. That means they add up to 180. In other words, 2x plus 1 plus x plus 5 must equal 180 degrees. And then we solve it from there by combining like terms. So we have the 2x and the x, of course, go together, and then the 1 and the 5 will go together. So that's why I'm going to get 3x plus 6 is equal to 180. And then it becomes a very easy problem to solve. So I've got 3x is equal to 174. So I would then divide both sides by 3. So that's 58. So x is 58. For problem number 2, keep in mind a theorem that we learned that related the words perpendicular, bisector, and perpendicular, bisector, and diameter. And what we learned was, if we are given 2 out of 3 of these, if we're given any 2 of these, we can conclude the third. We can assume the third. So we are given 2 of these things. See the little box there indicating that this is a 90-degree angle. That means that this chord is perpendicular to this chord. So we're given perpendicular. Now, see the dot that they have shown here? That dot represents the center. That means that this chord is the diameter. That means that we can conclude that this diameter is also a bisector. Bisector means it's splitting the other chord in half. In other words, this part is going to be congruent to this part. That's what bisector means. Equal halves. So that allows me to make the equation that 12x minus 12 must equal 10x minus 2. And that's how we solve this problem. If I subtract 10x from both sides, I get 2x minus 12 is equal to negative 2. If I then add 12 to both sides, that gives me 2x is equal to 10. And then I will turn around and divide both sides by 2. That's going to give me x is equal to 5. Now, problem number 3 involves one of those formulas that we just have to memorize. All right, we're talking about segments, not arcs. So I'm dealing with one of these 2 formulas. And you notice that the segments are reaching and meeting outside of the circle. So that means that we're dealing with this picture. So it's going to be outside times the whole thing is equal to the outside times the whole thing. So I'm just going to copy that formula down. So we're doing outside times whole is equal to outside times whole. All right, that's the formula. So if I look at this line for starters, the outside part is the 8. Now, the whole thing is going to be x plus 8. Okay, because the whole thing is all of it, the x and the 8. It's not 8x, it's x plus 8. You add these. Now, looking at this side down here, all right, as I do outside times whole, the outside is the 7, and the whole thing is 9 plus 7. Again, we're adding, not multiplying, so that's going to be 16. So a little distributive property here gives me 8x plus 64 is equal to 112. Now we need to subtract 64 from both sides. $48. And then I will divide both sides by 8. And that's going to be 6. So x is equal to 6. All right, for this problem, we really will use the same formula, even though it's a little bit of a special case because we have this tangent segment right here. But let's give it a try. It's still going to be outside times whole is equal to outside times whole. All right, we're still using that same formula. The top part is pretty straightforward because the outside is obviously the 16. And then the whole thing, is it 16x, people? No, it is not. It is x plus 16. You have to add these together to get the whole thing. All right, now, looking at this part down here, it's pretty clear that 20 is the outside, so I'm definitely going to put 20. But then what about the whole thing? Well, there is no other part, right? Like on for number 4, you have the 16 and you have the x. All right, there's two different, there's an outside part and then there's an inside part. So you can add those together and make the whole. But for the bottom here, the outside part is the only part. So that makes it also the whole thing is 20. So I wind up putting 20 twice. All right, it's 20 outside and also the whole thing is 20. So 20 times 20. So that's going to be 16 times x plus 16 is equal to 400. You know what? I might as well have done the distributive property on that step. So this will be 16x plus, right? Because I'm doing the distributive property. That's what I thought, but I wasn't sure. So 256 equals. Now I will subtract 256 from both sides. So that's going to give me 16x is equal to 144. And then I need to divide both sides by 16. So that is going to be 9. So x equals 9. For number 5, we have segments inside the circle. So that means we're dealing with this situation. So that's part times part is equal to part times part. Okay, so I'm just going to write that down. All right, part times part is equal to part times part. Okay, so for example, I can do x times 10, all right, because that's one chord, so the parts are x and 10. Or looking at the other chord, that's going to be 5 times 12. So this makes 10x is equal to 60, and if I divide both sides by 10, I'm going to get x is equal to 6. There's another theorem that we learned that said a tangent is always going to be perpendicular to the radius. So that means that I have a 90 degree angle here, which means that I can do the Pythagorean theorem to find this length right here. Okay? Let's see, what should I call this? You know how we go a squared plus b squared equals c squared? So I'm going to call this b just for a moment because I'm going to do the Pythagorean theorem. Okay, so here I go. A squared, so 6.6 squared, plus b squared is equal to c squared. So all right, 43.56. So now I'm going to subtract 43.56. So I'll have b squared is equal to 125.44. And then to get b by itself, we need to take the square root of both sides. So 11.2. Okay, 11.2. So that's the length of this entire red line. Okay, so the entire line is 11.2. That's the diameter. The x that we're looking for is the radius, so it should be half that. All right, so x should be 11.2 divided by 2. And that's 5.6. Number 7. All right, we've got this picture here, but the question is down below. So let's see. Arc BE is 92 degrees. Okay, so fine. Arc BE is 92 degrees. What else? Arc CD is 48. Here, I meant to make this darker. Okay, arc CD is 48 degrees. All right, that's what we have so far. And now we're supposed to find some other arcs and angles. So look, before I even look at that too hard, I can already see what I can find. All right, we're dealing with arcs and angles. So it's going to be one of those formulas. All right, these are segments, so those are not the formulas that we need. Okay, these are the formulas that I need. And specifically, it's going to be this one because of the way we're inside the circle. So that means that the angle is equal to arc plus arc divided by 2. So, in fact, I think I will just go ahead and write that down. Angle is equal to arc plus arc divided by 2. Now, the angle is right here, so I'm going to just call that x for a minute. So, because that's the one thing I don't know. So that means x is equal to, now these are the two arcs that are inside that angle. So 92 plus 48 divided by 2. That should give me the angle. That is 70 degrees. So that's this angle right here. So I now know that this is 70 degrees. So now I will look down and see what they actually are asking me to find. So they want angle DFC. Okay, DFC. All right, technically that's this angle down here. But of course, these are vertical angles, so they are equal. So these are both going to be 70 degrees. So angle DFC is 70 degrees. They also want me to find the measure of arc DEB. Okay, DEB would be the arc that went all the way around like this, from D through E and back to B. So let me come back to that for a second. Before I answer that question, it would be helpful to know the length of this arc right here. Okay, because that's a big part of DEB. So how can I find this purple arc? Well, I can use the fact that I know the diameter. All right, focus on this right here. This is a diameter. All right, it goes right through the center. That means this is a semicircle right here. So I should be able to subtract 48 to find the purple arc DE. Okay, so subtracting from 180, semicircle. So 180 minus 48, of course, is 132. So this is 132 degrees. So, again, arc DEB, all right, from D to E to B, that's just going to be the sum of the purple arc and the red arc together, make DEB. So that's just going to be 132 plus the 92. So that's 224. So I took a couple of steps. I hope you followed all of that. All right, for number 8, it looks like we have the same exact picture, but I guess we'll be given different information. So this time we're given that arc BC is 86. All right, so let's get that going. Arc BC What did they say that was? 86? Yeah. And the measure of angle BFE is 74. BFE. Let's see. Okay. And then they're asking us for some stuff. Let's see. They're asking us for angle DFE. All right. DFE is right here. So, you know what? We can go ahead and find that now. So this is what we're given. And now they're asking us to find the measure of angle DFE. Angle DFE is this angle right here. Okay, they're asking us to find this. Well, I hope you can see that this chord BD, you know, it's a straight line. So these have to add up to 180. So I should be able to simply subtract from 180. Subtract 74 from 180. So that's going to be 106. Okay, so that's the first thing they asked us to find. Now, they want us to find the measure of arc CD. Okay, arc CD is right here. Okay, they're asking us to find this. I'm going to go ahead and call it X since this is what we are looking for. Now, this angle is not at the center, so I don't get to just say, oh, it's going to be 74. These angles are both 74, so X is 74. I can't do that. It's not at the center. So instead, I need to use this formula. Angle is equal to arc plus arc divided by 2. That's the formula that represents this situation. There's one problem with that. If I make the bow tie or hourglass shape out of this, all right? So here's what I need, all right? So here's the bow tie hourglass type situation. That helps me know what the other arc is that I need. Can you see that the other arc that I need is this arc right here? I really need to know what that is. All right, I can't just use the 86 because I need the arc that's across from the X. Okay, they all have to be lined up inside the 74-degree angle. All right, this is inside of this angle, this is inside of this angle. I need this question mark before I can continue. So how can I find the question mark? All right, let me go back a step. I can find the question mark by realizing diameter. This blue line right here, A is the center, this is a diameter. That means the top part of this circle is a semicircle. So I should be able to subtract from 180 and find the missing arc. So that is what I'm going to do. If I do 180 minus 86, this should be 94. Okay, so that tells me that this arc right here is going to be 94. Okay, so now, all right, getting back to my hourglass shape, boom, 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 boom. Now I can do the formula. Angle equals arc plus arc divided by 2. Okay, so do I have room for this? Angle equals arc plus arc divided by 2. Always start off by writing the formula in words. The angle is 74, so that's why I'm going to put 74 equals. All right, arc plus arc, so that's x plus 94 divided by 2. So how do I solve an equation like this? I multiply both sides by 2. Multiply by the denominator. That way these 2's are going to cancel each other out. So this is going to give me 148 is equal to x plus 94. Okay, now all I have to do is subtract 94 from both sides. So that's 54. Okay, so x represented arc CD. So that's what I was trying to find. So I can go ahead and write 54. All right, problem number 9, we have a new picture. Let's scroll down and see what we are given. All right, arc LN is 24 degrees. All right. Arc KL is 38 degrees. Okay, that's what we know. Now we're supposed to find arc KJ. So this is down here. All right, let's go ahead and we can do that right now. All right, we are being asked to find arc KJ. But look, notice that this is a diameter. So what we have over here is a semicircle. So this has to add up to 180. So that means I should be able to subtract the 38 and the 24 from 180, and that should give me the KJ. So that's what I'm going to do. 180 minus 38 minus 24. That's 118. Okay, so we've got that. Now, okay, so 118, let's write that down. Now we're supposed to find the measure of angle M. All right, that's this angle way up here at the top. So I think I'll go ahead and call that X. All right, that's what we're trying to find, this angle. And we're dealing with angles and arcs, and we're outside the circle. That's this formula. Angle is equal to arc minus arc divided by 2. So I think we're ready to go. So let's just write that down. Angle is equal to arc minus arc divided by 2. Okay, so the angle is X. Now I need arc minus arc divided by 2. I have 3 arcs. How do I know which are the 2 I'm supposed to be using? All right, do I use 38 and 24? Do I use 118 and 38? Or do I use 118 and 24? Well, they have to be the arcs that are inside of the angle. So can you see that the angle goes like this and like this? So which 2 angles, which 2 arcs are inside that angle? That's the 118 and the 24. The 38 is outside the angle, so we do not use the 38. So again, that's why the two arcs will be 118 minus 24. The big arc minus the small arc, so you get a positive number. Okay, so that is 47. And that was the measure of angle M. Last problem, we've got this picture. Let's scroll down and see what we are given. We're given that the diameter is 24. Now, we know that the diameter goes from one side of the circle to the other, right through the center. So this is the diameter from J to N. All right, so that is 24. Now, of course, what that means is that this distance is the radius, so that is going to be 12. Okay, so I think that's what we're going to end up actually using. They gave us one other piece of information. Mn is equal to 1. Okay, Mn is this little outside piece right here, and we're told that that little piece right there is equal to 1. Okay, so this little piece right here is equal to 1. All right, now, of course, that means that the total side of this triangle right here is going to be 13. That's what that really means, all right? We've got the 12 and then the 1. So, yeah, go ahead and focus your eyes on this triangle. In fact, I think I will make it purple. Okay, we have this triangle that goes like this. All right, we've got this purple triangle, and the hypotenuse of that triangle is 13. I said hypotenuse. Don't forget about the theorem that tells us that the radius and a tangent are perpendicular. So that means this is a 90-degree angle. Okay, there's something else that we need to recognize. You know how the radius is 12? The radius is the same in all directions, no matter where you draw it. So I have a radius of 12 that I showed right here, but for example, down here is also a radius of 12, right? But also up here, this is also a radius of 12. Okay, so this is 12 as well. So really, when I look at this triangle, I have two sides that are given. I have the 12 and the 13. And one of the things that I'm looking for is the third side, LM. Okay? I guess the first thing, HM, that we're looking for, we already found that. HM is the hypotenuse of the triangle. And that turned out to be 13. So we might as well write that down. But now we're looking for LM. So LM is this right here. I'm going to call it X. Okay, so staring at this purple triangle, well, it refuses to stay on top, but we can just do the Pythagorean theorem. How do I know which side of the triangle? When, you know, we normally say a squared plus b squared is equal to c squared, which really means leg squared plus leg squared is equal to hypotenuse squared. That's how we know which side has to go over here by itself. It has to be the hypotenuse. So which one of these three sides is the hypotenuse? The x, the 12, or the 13? The 13 is the hypotenuse across from the 90 degrees. So the 13 squared goes by itself. And then it's leg squared plus leg squared. So this is x squared plus 12 squared. Right? So that means x squared plus 144 is equal to 169. If you subtract 144 from both sides, you're going to get x squared is equal to 25. And then, of course, you have to take the square root of both sides. And you end up with x is equal to 5. Now, remember that 5 represented the length of LM. And that's what we're supposed to be finding, so we can just go ahead now and say 5. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.